Okay, we have completed the adjoint of a matrix. Then we need to do the theorems. Okay, then we will do this one. I guess some of the students has missed some topics. Okay, so for 50 minutes, we will do the revision of our previous topic. And after that, we will start the new topic. Okay, so we have already done the adjoint. So I hope everyone know about the adjoint. Okay, Noma, you are already you are aware about the adjoint of a matrix.
Yes, sir.
Okay, good. Now after this, we have a theorem. Okay, there's a theorem that if A be any given square matrix of order n, then A into adjoint of A will be equal to adjoint of A into A, and that is equal to determinant into I. Okay, this is our first theorem, that A into adjoint of A into A is equal to determinant into I. So we will do the proof of this. Okay, so we have a matrix. Let A is equal to A11, A12, A13, A21, okay, A22, A23, A31, A32, and A33. Okay, this is the matrix we have. Now we will find the adjoint of this. Okay, so for the adjoint, we will find the cofactor. Okay, so we'll find the cofactor of this. So that will be equal to A11. Then we'll find this. We'll find this one. Next, we'll find A21, A22, and A23. This is A31, A32, and A33. This is the adjoint of the matrix. Next, we will multiply A into adjoint of A into adjoint of A. Okay, so this will be equal to what? A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, into adjoint of A. So that is A11, A21, A31, A12, A22, and A32, A13, A23, A33. Okay. Now after this is A into adjoint of A. This is equal to. Now you already know how we need to multiply two matrices. We will take the first row and first column. So A11 will get multiplied with A11, A12 will get multiplied with A12, A13 will get multiplied with A13. And finally, what we will get, you already know, as per the previous theorem, if you will multiply the elements of any matrix with its cofactor, with its corresponding cofactor, then you will get the determinant. So here we will get the determinant. First row will get multiplied with the second column. So these are the element of the first row. These are the cofactor of the second row. So if you will multiply the first row with the cofactor of the second row, then you will get a 0. Similarly, first row and third row, 0. Next, second row, first row, 0. Second row, second cofactor, determinant. Second row, third row, 0. Again, third row, first row, 0. Third row, second row, 0. Third row, third cofactor, determinant. Okay, we have this property that if we will multiply the elements of any row with its cofactor, then we will get the determinant. If we will multiply the elements of any row with a cofactor of any other row, okay, then we will get the 0. Okay, Yashika, Noma, Unib, you have joined almost 12-13 minutes late. Only if this is clear?
Yes, sir.
Okay. Noma and Yashika, this is clear?
Yes, sir. Yes, sir.
Okay, great. Now after this, we have A into adjoint of A, and this is equal to determinant. Okay, now from this complete matrices, we can take out the determinant common. So determinant into I. Okay, so this is the proof of this theorem. Please do this. Please complete this and let me know. Rishant, this is a maths class. Okay, so I guess by mistake you have joined this room. Okay, Rishant. So you can drop off and join the correct room. Yashika and Noma. Okay, Noma, I got your message. Yashika, this is done. Shall we start next?
Yes, sir.
Okay, great. Okay, Uneep, this done.
Sir, what is the adjoint of a set? Sir, please explain.
Uneep, you were present in the last class,
Yes, sir.
but we have completed this topic last Sunday.
Yes, sir. Can you explain? Just revise it.
I guess you have drop off half an hour or 1 hour earlier. Am I correct?
Yes, sir. Can you repeat?
Uneep, I'm already repeating this topic. So first of all, please let me know what was the reason?
Yes, sir. I was asking, can you please repeat what you said just now?
Uneep, what is the cofactor? Uneep, what is the cofactor?
Yes, sir. सर कोफैक्टर आपने पढ़ाया था सर, उसके बाद एडजॉइंट मैंने नहीं लिखा।
Adjoint is related with the cofactor. What is cofactor? How you find the cofactor of an element of a matrix? Uneep, what is a minor? Minor of an element of a determinant?
Sir, when we remove the row and column of the matrix. The remaining element is the minus.
Very good. And what's the cofactor?
Cofactor is the minus multiplied by the -1 to the power the row and column of the sum of the row and column of the.
Okay, good. Okay, please remember this. If you have a matrix, suppose 1, 2, 3, 4, or we can say A11, A12, A21, A22. Okay, there's a matrix. First of all, you need to find the cofactor. So now you already know how can you find the cofactor of the elements. Okay, and to find the adjoint of a matrix, what you will do, you will write the cofactor in place of the elements. And after that, you will find the transpose of this matrix. Okay, so if you will find the transpose of this, then you will get A11, A12, A21, and A22. Okay, only this clear?
Yes, sir.
Okay, so first of all, please find the cofactor and write them in place of the elements, and then find the transpose of this matrix. So you will get this one. Okay. Okay,
Yes.
so only please note down this.
Yes, sir, I have noted.
Okay, very good. Okay, so this was our first theorem. Okay, that A into adjoint of A is equal to adjoint of A into A is equal to determinant into R, where I is the identity matrix of order n. Okay. Now there's a second theorem that if A and B are non-singular matrices of the same order, then AB and BA are also non-singular matrices of the same order. So first of all, Uni, what are non-singular matrices?
Sir, whose determinant is not 0.
Very good. Whose determinant is not equal to 0. So if we have two matrices, for example, A and B, and we know that determinant of A is not equal to 0 and determinant of B is also not equal to 0. If we will multiply AB and we will find the determinant, okay, so this will also be not equal to 0. Similarly, if we will find the BA and we will find the determinant, then this will also be not equal to 0. So this is the theorem. If A and B are non-singular matrices of the same order, then AB and BA are also non-singular matrices of the same order. Okay, so Noma, Yashika, Uni, this is clear?
Yes, sir.
Okay, good. Okay. Uni, this clear?
Yes.
Okay. Atif, Huzefa, Maziha, and Saf. Okay, please wait for 15 to 20 minutes. Okay, we will start the new topic shortly.
Okay, sir.
Okay, Saf. Good. And Yashika, Noma, and Uni, please let me know once it is completed. And Mazia, this theorem is clear? Any doubt in this theorem?
Yes, sir, it's clear.
Okay, very good. And Mazia, please let me know if you miss any of the topic. Okay, I guess this topic was not completed. Okay.
No, sir, I was there in the other class where you were started.
Okay. Okay, Noma, I got your message. Yashika and Uni, this completed. Shall we start next?
Yes, sir.
Yes, sir.
Okay, good. Now we have the third theorem. The determinant of the product of matrices is equal to the product of their respective determinant. So what does this mean? Suppose we have two matrices A and B. We are multiplying these two matrices and we are finding the determinant of these two. Okay, we are multiplying these two matrices and then we are finding the determinant of these two. Then this will be equal to determinant of A into determinant of B. So we have two matrices, we are multiplying them, and then we are finding the determinant. Then that will be equal to, if we will separately find the determinant and we will multiply these two. Okay. So this is clear. Noma, Yashika, Anani, this clear?
Yes, sir.
Okay. Yashika and okay, only got your message. Yashika, this clear?
Yes, sir.
Okay, okay, very good. So please note down this and let me know, then we will start the next topic. Shall we start next? Noma, Yashika, and Anani?
Yes, sir.
Okay. Yashika, Munib?
Yes,
Will
sir.
you- Okay.
Yes, sir.
Okay, good. Okay. A and B are square matrices of the same order. Okay. So please complete this sentence in the same order. Now, next one. If A is a non-singular matrix of order n, then adjoint of A is equal to determinant n minus 1. Okay. Now we will do the proof of this theorem. Proof. Now A into adjoint of A is equal to adjoint of A into A is equal to. Anyone can tell me this one? Yashika, can you tell me what is the theorem? A into adjoint of A.
Determinant A into I.
Determinant of A into I. Very good. Okay, so we have this theorem. Now, we have this. Let A is equal to uh, let matrix A. Let matrix A have the order. Let matrix A have the order 3. Okay, so that means A into adjoint of A, this is equal to determinant of A. Okay, now if the matrix A have the order 3, then this identity matrix should also have the order 3. So that means identity is 1 0 0 0 1 0 and 0 0 1. If you will multiply this determinant with this matrix, and what you will get, A into adjoint of A, this is equal to, you will multiply this determinant with all the elements. So you will get determinant of A 0 0 0, determinant of A 0 0 0, determinant of A. Okay, please remember this property. If you're multiplying any element, if you're multiplying any scalar with a matrix, and all the elements will get multiplied with that. Now, if we will take a determinant on both sides, so we will get A into adjoint of A, and this is equal to, determinant of A 0 0 0, determinant of A 0 0 0, determinant of A. Okay, now if you will check our previous property, this one, determinant of AB is equal to determinant of A into determinant of B. Now here also we have two matrices, A and adjoint of A. So if we are finding the determinant of this, so this will be equal to determinant of A determinant of adjoint of A, and this is equal to, now in case of determinant, you need to take a common from each row or column. So from the first row, we will take a determinant A common. Okay, from the second row, we will again take determinant A common. From the third row, we will take determinant of A common. So this we will get 1 0 0 0 1 0 0 0 1. Okay, Unip, can you tell me what is the determinant of this 1 0 0 0 1 0 0 0 1? What is the determinant of identity matrix?
Sir, 1.
1. Very good. Okay, now here we have a determinant of A. Here we have 3 times determinant of A. So this will get cancelled out. So we get adjoint of A determinant is equal to determinant square into 1. So this we will get adjoint of A. In place of this square, we can write 3 minus 1. Okay, now please check the theorem. What's the theorem? If A is a non-singular matrix of order n, then adjoint of A determinant is equal to determinant n minus 1. Okay, where n is the order of the matrix. So if we will check this case, the order of the matrix A is 3. So we are getting adjoint of A determinant is equal to determinant 3 minus 1. The same was there in the theorem. Okay, I hope this is clear to everyone. So please remember, if you need to find the adjoint of a determinant, then you can find it. You can find the determinant of the matrix, and then you can put this formula n minus 1. Okay, Noma, Uneep, and Yashika, this is clear?
Yes.
Okay,
sir.
good. Okay, good. Uneep?
Yes, sir.
Okay, very good. So please note down this, confirm me, then we will start the next talk. Okay, Noma, good. Uneep and Yashika, this is done.
Yes, sir.
Okay, good. Uneep, this is done. Shall we start next?
Sir, just a minute.
Okay.
Yes, sir, done.
Okay, our next topic is inverse of a matrix. Okay. Now, Suppose we have a matrix A and we will multiply this matrix A with another matrix B, and we are getting a identity matrix. Okay, suppose we have a square matrix A, we will multiply this matrix A with matrix B, and we are getting an identity matrix. And in such a case, B is said to be B is said to be the inverse of A. Is said to be the inverse of A. Okay, if we will take this as example of a real number, suppose we have a 2. So we will multiply this with some number so that we will get a 1. So what that number will be? 1 by 2. So similarly, if you will multiply A with another matrix B and you are getting an identity matrix, then you will say that B is the inverse of A. Okay, if you are multiplying A with B, you are getting identity, then B is said to be the inverse of A. Inverse of A is denoted by A inverse, like this. Inverse of A, or we can say inverse of a matrix A, is denoted by this symbol. So that means A inverse is equal to what? This is B. So the same thing is written in this definition, that if A is a square matrix of order n, okay, now what is meant by invertible? If the inverse of a matrix exists, then we will say that the matrix is invertible. Okay, if inverse of a matrix exists, then we will say that matrix is invertible. So if in exam they will ask you that please check the matrix is invertible or not, then you need to check that the inverse exists or not. If the inverse of a matrix exists, then it is said to be invertible. Now the definition is square matrix of order n is invertible if there exists a square matrix B of the same order such that AB is equal to BA is equal to identity. Okay, a square matrix of order n is said to be invertible if there exists a square matrix B such that AB is equal to BA is equal to I. In such a case, we say that the inverse of A is B and we write A inverse is equal to B. So the only point which you need to remember is if you need to find the matrix A, sorry, if you need to find the inverse of A, then you need to find a matrix B such that if you will multiply A and B, you will get the identity matrix. This is clear? Noma, Yashika, and Duni?
Yes.
Yes, sir.
Okay, okay. Then please note down this one. Let me know, then we will continue this topic. This is done. Noma, Yashika, Uni.
Yes, sir.
This okay. Uni, this done.
Yes, sir.
Okay. Yashika, shall we start next? Okay, okay, very good. Okay. Now next property is a square matrix A is invertible if and only if A is a non-singular matrix. Okay. So what is the condition? Square matrix A is invertible if and only if A is non-singular matrix, or we can also say that inverse of a matrix exists only if it is non-singular matrix. Okay, so if in your exam in 1 mark question they will just ask you that the inverse of this matrix exists or not, then you will find the determinant of it. If determinant is not equal to 0, then inverse exists. If determinant is equal to 0, then inverse does not exist. So inverse will exist only if the matrix is non-singular. Please remember this property that a matrix, that inverse of a matrix exists if its determinant is not equal to 0. Okay. Now at A into adjoint of A, this is equal to determinant into I. This we have already completed. A into adjoint of A, this is equal to determinant into I. Now shift this determinant to the left side. So you will get A into 1 by determinant adjoint of A, and this is equal to identity matrix. Now if we will compare this with the definition, what is inverse of a matrix? If there exists a matrix B, so that if we will multiply this with A and we are getting identity, then we will say that the inverse of A is B. If we will compare this with the standard definition of an inverse, then you are multiplying this matrix A with this complete matrix and you are getting identity. That's why you can say that the inverse of the matrix is equal to 1 by determinant of A adjoint of A. So this is also the formula to find the inverse of a matrix. What you will do, you will find the adjoint of A, you will divide that with the determinant of A, you will get the inverse of a matrix. Okay. Now, always remember in mathematics in the denominator, we do not have a zero, otherwise this will become not defined. Now, in what case this inverse exists? When this determinant is not equal to zero. In which case inverse will exist? When the determinant will not equal be, when the determinant will not be equal to zero, because the determinant is in the denominator. Okay, so inverse will exist. A inverse exists when determinant of A is not equal to zero, that is determinant A is that is A is non-singular. A is non-singular. So inverse of a matrix exists only if A is a non-singular matrix. And this is the formula to find the inverse of a matrix. You need to find the determinant, you need to find the adjoint of A, then you will divide the adjoint of A with the determinant, you will get the inverse. Okay. So I hope this property is also clear to everyone. So please note down this property and confirm me. Then we will do one question on the basis of this property, and then we will start a new topic. Okay, so Noma, Yashika, and Uni, please confirm me once it is done. Okay, Noma, very good. Yashika and Uni, this is done. Shall we start next? Yashika and Uni, this is done. Shall we start next? Uni and Yashika, this done.
Sir, just a minute.
Okay, okay. Nashad, I've just realized that you have joined this batch. This is a maths class.
Yes, sir.
Okay, so they have given you this timing because our next batch will start after 1.5 hours from now.
So this is my actual trial classes, so thus
Okay.
I just joined.
Okay. Nishad, actually, we are just doing the last part of the chapter. So this is possible that you will not be able to understand it. Okay.
Yes, I am not understanding.
Yes. So you can join at 9 p.m. IST. Okay, Indian Standard Time. A new batch will start today. So I guess that will be better for you.
All right, sir.
Okay. Okay, so Unib and Yashika, this is done. Shall we start next?
Yes, sir.
Okay,
Yes,
good. Okay, so please note down the last point also, that this theorem provides us a formula for finding the inverse of a non-singular matrix, and the inverse is given by this one. I hope you have already noted down this. Okay, now we'll do just a single question on the basis of this, then we will start a new topic. The question is find the inverse of the matrices. Okay, so I have already told you that what is the formula to find the inverse of a matrix. So inverse is given by 1 by determinant of A adjoint of A. Okay, now first of all we will find the determinant so that we can check that the inverse will exist or not. So determinant of A is what? 2, -1, 3 and 4. Now cross multiply this one, this will become 8 minus plus 3, so we get an 11. Now next we will find the adjoint of A. So for the adjoint we need the cofactor. So A11 will be equal to what? -1, 1 plus 1. Okay, first row, first column, ignore this, 4. So this is equal to 4. A12, first row, second column. So here we will get a -3. Next we will get A21. So second row, first column, we get a +1. Okay, as per this formula, we will have a negative sign in the formula, so we'll get a positive answer. A22. So here we'll remove this one, so we get a 2. Now adjoint of A is what? Adjoint of A is equal to adjoint of A is equal to transpose of A11, A12, A21, A22. We'll find the transpose of this. So this will be equal to what? This will be equal to A11, A12, A21, A22. And this will be equal to what? 4. A21 is 1. This is -3. Sorry. And this is 2. Okay, so adjoint of A, we will get this one. Now, what is the inverse? Inverse is equal to 1 by determinant of A. Okay, adjoint of A. This is equal to, now the determinant is 1 by 11, 4, 1, -3 and 2. So you will divide all the elements with 11 and you will get 4 by 11, 1 by 11, -3 by 11 and 2 by 11. Okay, Noma, Yashika and Uneep, this is clear?
Yes, sir.
Okay,
Yes, sir.
very, very good. So please note down this, confirm me, and then we will start a new topic. Okay, Noma, good. Yashika and Uneep, this is done. Shall we start next?
Yes, sir.
Okay. Uneep, this is done.
Just a minute.
Okay.
Sudden.
Okay, Mani, very good. Okay, so please remember this formula that A inverse is equal to 1 by determinant adjoint of A, and you need to check that A is a singular matrix or not. So I hope all of you know how to find the inverse of a matrix. And there are some more questions which are based on this inverse of the matrix, and we will do that questions later on. Okay, Noma and Yashika and Uni. There are 5 or 6 questions which are based on this. We will do that later on. Now we will start a new topic, which is application of inverse of a matrix. Okay, so we have the properties of inverse of a matrix. You can note down this, and we will do some questions on the basis of this property later on. Okay, so the first property is AB inverse is equal to B inverse A inverse. Okay, so if you are finding the AB and you are finding inverse, so that will be equal to B inverse A inverse. That's opposite. It is not A inverse B inverse, it is B inverse A inverse. Okay, please note down this property, and Noma, Yashika and Uni, please confirm me once it is done.
Done.
Okay. Unib and Yashika, this time.
Yes, sir.
Okay. Unib, this time. Unib, shall we start next?
Yes, sir.
Okay. Now, the second property is A inverse is equal to A. Okay, if you are finding the inverse 2 times of a matrix, then you will again get the same matrix. Please complete this. I will give you 30 minutes, 30 seconds for this. Please complete this one and confirm me. I guess everyone has completed this. Please check the third one. Third is, this is a sign of transpose. Okay, if you're finding the transpose of a matrix, if you find the transpose of a matrix, and then you have find the inverse, then that will be equal to, if you will find first inverse, and then you will find the transpose of that. Okay, so if you're finding the transpose of a matrix, and then you're finding the inverse, that will be equal to, yes, Naushad, please, if you wish, you can leave the class, okay? And we have a new batch at 9 p.m. today, 9 p.m. IST, okay? Okay, thank you. Okay, so this A transpose inverse is equal to A inverse transpose. Okay, hope this property is also clear. Now the fourth property, if you're finding the adjoint of transpose of a matrix, so you have a matrix, you have find out the transpose of this, then you are finding the adjoint. So that will be equal to, if you will first find the adjoint of a matrix and then you will find the transpose of it. Okay, if you find the transpose of a matrix and then you find the adjoint, so that will be equal to, first find the adjoint of the matrix, then find its transpose. Please note down these properties up to 4, then we will check some more properties. Please confirm me. Okay, Noma, Yashika and Uni, once it is done.
Done.
Done. Okay. Unib and Yashika, this one. Unib and Yashika, this done.
Yes, sir.
Okay. Okay, hope everyone has done this. Now next property. If you're finding adjoint, if you'll find the adjoint of a matrix, then you will find again the adjoint of this. Okay, and you will find the determinant of this. So that will be equal to determinant n minus 1 whole square. Previously, we know this, that adjoint of a determinant is equal to determinant of a n minus 1. Now, if you will find one more adjoint and then find the determinant, that will be equal to determinant n minus 1 whole square. Okay, so this is the fifth property. Now, the sixth is, if you will find the determinant of inverse of a matrix, and that will be equal to 1 by determinant. Okay, so you can directly find the determinant of A, and if they ask you to find the determinant of inverse, then you can put this property 1 by determinant of A. So I hope this is clear to everyone. Noma, Unib, and Yashika, please complete this and let me know. Then we will start the next topic. This is done. Shall we start next?
Yes, sir.
Okay. Noma, this time.
Yes, sir, done.
Okay. Unib, shall we start next?
Yes, sir.
Okay, good. Okay, so next we will start the application of determinants and matrices. Okay, so this is a new topic for all of you. Okay, Atif, Josefa, and Mazia, and Saf. Okay, so I hope
Yes.
all of you have completed the previous questions which I have given in the last class. Now we will start the next topic, that is the application of determinants and matrices. We can use matrices and determinants to solve the linear equations. So in class 10th, you have solved linear equations in two variables. Okay, and you have a different method for that: elimination, substitution, cross multiplication. Now in class 12, we will use the determinant and matrices to solve those equations. Okay, but before that, first of all, we will revise the same concept of class 10th. Okay, so first thing is consistent system. Anyone can tell me that when we can say that the system of equation is consistent?
When the solution exists.
When the solution exists. Okay, so for example, if we have two equations, 2x plus 3y is equal to 4, 4x plus 9y, 4x plus 8y is equal to 6. Suppose we have these two equations. Anyone can tell me what is the graph of, yes, Noma, you are correct. What is the graph of linear equations in two variables? What is the graph of linear equation in two variables? A straight line?
Straight.
So if you have two equations, then you have three possibilities. Okay. First is your line. Suppose these are your lines and they intersect at a point. You have three possibilities. If you will draw the graph, then your line will intersect at a single point. Second possibility you have that line will overlap. This is the first line and the second line will lie on the same line. Okay. Third possibility you have that you have two straight lines and they are parallel. Okay. So if you will draw the graph of linear equations having two variables, then you have three possibilities. First, the line can intersect, the line will overlap, and the third one is line will be parallel. So for the first case, we can say we have the unique solution. In the first case, we will say that we have unique solution. Unique solution means only a single solution exists. So the point of intersection will give us a unique solution. In second case, as both the lines overlap, so we have infinite solution, or we can say many solution. Many solution or infinite solution. Infinite solution. So we have these two cases, many or infinite, unique solution. Now the third, when the line do not intersect, then in this case we have no solution. If line do not intersect, then we do not have any solution. So we will say no solution. So we have three cases: unique solution, many solution, and no solution. You have already done this in class 10th. Okay, these unique, no, and many you have already completed. Now, what is a consistent system? If the solution exists. Solution exists means unique or many solution. So both these two cases will come under consistent. If you have two equations and you will solve them and you're getting a unique solution, then you will say that the system of equation is consistent because the solution exists. If you will solve the equation, you will get many solutions and you will say that the system of equation is consistent. Okay, so when we will say that the system of equation is consistent, when solution exists. Solution can be unique solution or infinite solutions. Okay, so this point is clear to everyone that what is a consistent. Atif, Huzefa, Mazia, Saf, Noma, Unib, and Yashika. This is clear?
Yes, sir.
Okay, everyone please reply me on the chat box, all the other students, or unmute yourself. Please confirm me. This is clear? Okay, Saf. Okay, Mazia, good.
Yes, sir.
Okay, Noma. Okay, Yashika. Anyone is left? Unib. Unib?
Yes,
this-
sir.
Okay. Okay, so this was a consistent system. Consistent means solution will exist. That can be many solution or unique solution. Now, second is a inconsistent. Inconsistent is when the solution do not exist. So that means no solution. Okay, if you have two equations and there is no solution, then you will say that the system of equation is inconsistent. So please remember this: consistent means solution exists, inconsistent means solution does not exist. Okay, please note down these two and confirm me, then we will do the next topic. This is done. Shall we start next? Adif, Huzefa, Mazia, Saf, Noma, Unib, and Yashika. Okay, Noma. Okay, good. Okay, sir. Very good. Okay. So I hope everyone has completed this. Okay, we will check the next topic. Now, next is solution of system of linear equations using inverse of a matrix. Okay. Now here we will check that how can we solve linear equation using inverse of a matrix. Okay. As we have already discussed that in class 10, you will solve the system of equations by three methods. Now here we will use the determinant method. Now, suppose we have these three equations. a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. These are three equations. This is the first equation, this is second equation, and this is third equation. Here a1, b1, c1 are constant, x, y, z are variable. d1 is also a constant. Okay, for example, if we have this equation, 2x plus 3y plus 4z is equal to 6. For example, this. Similarly, in second equation, a2, b2, c2, and d2 are the constant, x, y, z are variable. Similarly, in the third one, a3, b3, c3, d3 are constant, x, y, z are the variables. Okay. So we have these three equations. We will check that how can we solve these three equations. Now, first of all, from these constants, we will form a matrix. Matrix A we will form by taking these constant, these coefficient we can say A1, B1, C1, A2, B2, C2, A3, B3, C3. So the matrix A will always be from these constant A1. And please do not disturb the sequence. Always take in this sequence. First of all, coefficient of X, coefficient of Y, coefficient of Z. This X will always be the variables. Okay, so in this case, we have three variables. We will take X, Y, Z. Please take in this order. Next, we have, if the equation have only two variables, then ignore the Z. In this equation, we have three variables. That's why we have taken the Z. Now, B will always be D1, D2, D3. Okay. So A will always be formed from the coefficients of the variable. X will always be formed from the variable, and B from the last constant. And we will take the order like this one. Okay. Now we will check one point, that what happens if we will multiply A into X. Okay. So what is A into X? And if we will do like this, AX is equal to B, then we will check that what we will get. What is A? A is A1, B1, C1. This is A2, B2, C2. This is A3, B3, C3. Okay, and X is X, Y, and Z, and this is equal to D1, D2, D3, D1, D2, and D3. Okay, now first row, first column. Okay, we will multiply this, and what we will get? We will multiply the first row with the first column. So we will get A1x plus B1y plus C1z. Next is A2x plus B2y plus C2z. Next is A3x plus B3y plus C3z. And this is equal to D1, D2, D3. D1, D2, D3. Okay, now equate this. So first equation will be equated with D1. So we will get A1x plus B1y plus C1z. This is equal to D1. Similarly, A2x plus B2y plus C2z is equal to D2. A3x plus B3y plus C3z is equal to D3. So please check, if we will multiply this AX and we will equate this with B, then we will again get the same equation. So that means this equation is correct. AX is equal to B, this is correct. Okay, so whenever you have a matrix, then you will always take A as a coefficient of X, Y, Z, X as the variable, and B as D1, D2, D3. Okay, and this is also correct, that AX is equal to B. Okay, there's no need to note down this. AX is equal to B is correct. Now, we have this one, AX is equal to B. Okay, now we will multiply, let this be 1. Multiply 1 by A inverse. Multiply 1 by A inverse. Okay, so it's your choice. You can multiply from this side or this side. This is your choice. Okay, but we will multiply from this one because we need to remove this A. So A inverse A X is equal to A inverse B. Always please remember, if you're in a matrix, if you're multiplying with any matrix, then it's your choice. You can multiply from this side or from this side, but please maintain the sequence. As you are multiplying from the left side, so A inverse we will write on the left side, and similarly after this equal to we will write on the left side. Now who can tell me, Uneet, what is A inverse into A?
Sir,
I, very good. Okay, so A inverse into A is I x is equal to A inverse B. Okay, now Uneet, what is I into X?
X.
X. Okay, if you will multiply any matrix with identity, you will get the same matrix only. So X is equal to A inverse B. So what value we need to find? We need to find the variable. Variable is what? X. So we will use always this formula that X is equal to A inverse B. There is no need to do the derivation. Okay, we will just use this formula that X is equal to A inverse B, but always please remember that what is A, B and X. What is A? A will be found from the coefficient of the variable. What is B? B will be the numbers which are on the right side of the equality, and X you already know that X is a variable. Okay, so we will always use this formula X is equal to A inverse B. The same thing is written over here. Okay, this one X is equal to A inverse B. Okay. So please note down this complete. Let me know, then we will check some more topics on the basis of this one. Please note down this.
So in B, we'll write the constants, right?
Yes. Which one? Yes. D are the constant. D1,
Okay.
D2, D3. Okay.
Done. Sir.
Okay. Good. And all the other students, will you please confirm? Shall we start next? Okay. Josefa, Maziha, Noma, Unib, Yashika.
Yes, sir.
Okay, good.
1 minute, sir.
Okay, okay. Okay, Yashika, good. Unib, shall we start next?
yes, sir.
Okay, good. So I hope everyone has completed it. Okay. Okay, next one.
So can you show me the last slide? 1 minute.
Yes, yes. Sure.
Done, sir.
Okay, very good. Now next one. We have some cases. Okay. We already know that we have three types of cases: unique solution, no solution, and many solution. Okay. We will check the cases like this. If you have three equations and you will find the determinant of A. What is A? A we will get from the coefficient of X, Y, and Z. So if you will find the determinant of A and determinant is not equal to 0, this is 0. Okay? Determinant is not equal to 0, then the system of equation is consistent and has a unique solution. Okay, So if you will find the determinant of A and that is not equal to 0, so that means the equation have the unique solution, consistent and has a unique solution, and that will be given by x is equal to A inverse B. This formula we already know that we will use this formula to find the value of x, y, and z. Okay, so please remember the first case, determinant of A is not equal to 0, then the system of equation is consistent and has a unique solution. These types of cases can come in 1 mark. Okay, they will give you an equation and they will ask you that the system of equation is consistent or inconsistent. So in such a case, there is no need to solve the equation. Okay, just find out the determinant, and if it is not equal to 0, this is 0, then the system of equation is consistent and has a unique solution. All of you, please note down this case 1, confirm me, then we will start the second case. Please reply me, okay, once it is completed, so that we can start the second case.
Done, sir.
Done.
Okay, Atif. Okay, Noma. Okay, Masia. Good. Josefa, Seth, Munib, Yashika.
Done, sir.
Okay. Josefa and Seth. Anunib. Shall we start next?
Yes, sir.
Okay. Okay, Seth. Good. So I hope everyone has completed this. Now we will check the second case. Second case is if determinant is not if you find out the determinant of A, and this is equal to 0. If determinant is equal to 0, okay, please remember this is 0, this is 0. I will write here. This is 0. Similarly, this is also 0. Okay. If determinant of A is equal to 0, in that case, you will find adjoint of A into B. You already know how we can find the adjoint of A. If determinant of A is equal to 0, then we will find adjoint of A into B. And if that is equal to null matrix, now this is a null matrix. Okay. Null matrix. This one. If adjoint, then we will find adjoint of A into B, and if that is not equal to null matrix, then the system of equation is inconsistent and has no solution. Okay, so in the first case, we have find out the determinant of A that is not equal to 0. So that means consistent and unique solution. Now, if you will find the determinant and that is equal to 0, in that case, you will find the adjoint of A into B. And if that is not equal to null matrix, then the system of equation is inconsistent and has no solution. Okay, so I hope this second case is also clear to everyone. These types of these cases will be used for 1 mark question. Okay, please note down this, confirm me, then we will check the third case. If anyone have a doubt, then please let me know. Okay.
Done.
Okay, very good. Everyone please confirm. Huzefa, Maziha, Saf, Noma, Unib, Yashika. Shall we start
Yeah.
next? Okay, Saf. Okay, Noma. Okay, Maziha. Okay, Unib. Okay, Yashika. Okay, so I guess everyone has completed this. Now we will check the third case. Now third case is if you find out the determinant, this is again 0. Okay, this is 0. And you'll find if this is 0, then you'll find adjoint of A into B. And if it is equal to the null matrix. Okay, this is null matrix. Null matrix. Okay. If this is equal to null matrix, it's a system of equation may be either consistent or inconsistent according as the system have many solution or no solution. Okay. So if you get a determinant 0 and you have find out the adjoint of A into B and that is equal to null matrix, then there are chances that the system have many solution or no solution. Okay. So in case third, there are again some rules by which we can check that the system is consistent or inconsistent for this case third. Because in the case third, we have checked that system of equation can be consistent or inconsistent. Okay, so in case third, we have further some process by which we can check that it is consistent or inconsistent, but that is not in NCRT. So we will not do that. We will just do these three cases, straightforward cases. First, determinant equal to 0, unique solution consistent, equal to 0, then adjoint of A, B, we will find. If this is not equal to null matrix, then no solution, inconsistent. Third case, determinant 0, and this is equal to null matrix, then equation may be consistent or inconsistent. Okay, so we will just do the very straightforward cases, first, second, and third. These cases are clear to everyone.
Yes, sir.
Okay. Atif, Huzefa,
Can you
Masih.
explain the third case again?
Yes, sir, I will. Okay, please check the third case. So we will again write from here. So in the first case, we will find determinant and this is not equal to 0. So everything is fine here. Here we have the consistent unique solution. In second case, if determinant is equal to 0, then what we will do? We will find adjoint of A into B. If this is not equal to the null matrix, if this is not equal to the null matrix, then no solution, inconsistent. Now third one, determinant 0, then again we will find adjoint of A into B. If this is equal to the null matrix, then in that case, the equation can be consistent or inconsistent. Okay, that depends. If you will get an infinite solution, then it will be consistent. If you will get no solution, it will be inconsistent. Okay, so there is further process by which we can check it has a many solution or no solution, but that is beyond the scope of our syllabus. Okay, sir?
Okay, sir.
Okay. So I hope this is clear to everyone. So please note down the third one, case third, and confirm me. Then we will do some questions on the basis of this third case. Sorry, on the basis of these cases. Everyone, this is done. Shall we start next? Everyone?
Yes, sir.
Okay. Atif, Maziha, Huzaifar, Uneep, Yashika. Shall we start next?
Yes, sir.
Okay, sir. Okay, Uneep. Everyone else? Yashika, shall we start next?
Yes, sir.
Okay. So I hope everyone has completed this. Okay. These are very simple cases, first, second, and third. Now we will try some questions on the basis of these cases. Now the first question is examine the consistency of the system of equations. Okay. So first equation is this. Okay. There is no need to solve the complete equation. You already know the case first, second, and third. So please check that the solution is consistent or inconsistent. Okay, in case consistent, then have the unique solution or what. Please try this question. I will give you 2 minutes for this. Okay, this is a very, very simple question. Please let me know if anyone have a doubt in this. Noma, very good. This is correct. And other students, can you tell me what is the answer? Is it consistent or inconsistent? Yashika, very good. Your answer is correct. Saf, very good. This is correct. Atif, good. This is correct. Huzaifar, please share your answer. Maziha, please share your answer. Uni, please let me know if it is completed and share your answer. Deep, this is done. Huzaifar, Maziha, this is done. Okay, Huzaifar, I will do this. Okay. Maziha, this is done. Uni, this is done.
Yes, sir.
Okay. Maziha, what's the answer? Uni, what's the answer for this? Very good, Uni. Okay, so please write consistent also. Okay. Maziha, what is the answer? Maziha, what is the answer of this? Maziha? Mazir, please let me know if you have a doubt in this. Okay, Josefa, so can you tell me what is matrix A? Josefa, can you tell me what is matrix A? Josefa, if you don't know the answer, then please let me know so that I can explain you. Okay, Josefa, always remember as we have discussed as we have discussed here, that this matrix A will be formed from these coefficients. Okay, A will be formed from these coefficients. X will be from the variable and B from the constant D1, D2 and D3. Okay, so in this question, A will be 1 because the coefficient of X is 1, coefficient of Y is 2, this is 2 and this is 3. So matrix A will be 1, 2. Whoever matrix will always be a square. Okay, because we need to find the inverse and inverse will exist when it is a square. Okay. Okay. So A, we will get this. X is what? We don't need X and Y here, but we will write it so that in next question, we will get some help. And B will always be what? 2 and 3. 2 and 3. Okay, so A is 1, 2, 2, 3, X is XY, and B is 2 and 3. Now, Josefa, if you will check a first case here, then the first case is what? Find the determinant of A first. Now, in this question, we will find the determinant of A. Determinant of A is what? 3 minus 2 into 2. Very good. So this is minus 1. So determinant is not equal to 0. So Josefa, as per the first case, the system of equation will be consistent or inconsistent? Josefa, inconsistent. Why inconsistent? Please check the first case, Josefa. Determinant is not equal to 0. Check the first case. When determinant is not equal to 0, then the system of equation is what? Consistent or inconsistent? Consistent, okay, and have unique solution. So for this case, our answer will be consistent. This is clear, Josefa? So you just, for these type of questions, for the 1 mark question, you just need to find the determinant and then you need to check this if this is not equal to 0 and this is consistent. Okay, please note down, Josefa, this one and try the second question and let me know the answer. Everyone, please try this second one, okay? And let me know if anyone have a doubt in this. Atif, very good. This is correct. Okay, Oni, but please check the recorded lectures, okay? Because today we will do a very important topic.
Sir, how long will it take?
25 more minutes. Okay.
Okay, sir.
From today onwards, you have a 2-hour class.
Okay, sir.
Uni, just a minute. Can you wait for 10 minutes? Because I need to start a new topic. So if you can wait just for 10 minutes so that you can understand that how we need to solve the questions. After that, you can leave. Is it
Okay.
possible? Okay, thank you. Okay, Yashika, very good. This is inconsistent, good. Good, Noma, this is inconsistent. So all of you have find the adjoint of A into B also, okay? Okay, Atif, very good. Masiha, and Josefa, Saf, please give your answer for this. Josefa, Saf, and Mazia, please share the answer or let me know if you have any doubt in this one. Okay. Very good, Saf. Very good, Josefa. This is correct. Okay, Mazia, I guess you have already solved it. Okay, so this is inconsistent. You will find the determinant, and determinant is what? 0. So now we have two options, either case 2 or case 1. So if we will check the previous cases, then if determinant is equal to 0, then we will find adjoint of A into B. Okay, so now here we will find the adjoint of A into B. What is B here? B is 5, 8. Next, we will find the adjoint of A. What is A? A is 1, 3, 2, 6. Next, find A11. This 6, A12. This is -2, A21. This is -3, A22. This is 1. Now, adjoint of A will be equal to 6 minus 2. Okay, I'm writing the values directly. -3 and 1. Now, we need adjoint of A into B. So what we will get? We will get 6 minus 3 minus 2 and 1 into B. B is what? 5 into 8. Sorry, 5 and 8. So multiply this. First row, first column. So 6, 5, 30. Okay, and minus 24. Minus 10 plus 8. So this will give us 6 minus 2. So if you are finding the adjoint A into B, then this is not equal to null matrix. Okay, so this is the second case. So that means inconsistent. So I hope everyone have solved this by this method. And if anyone have a doubt, then please let me know. Okay, and Mazia, if you have any doubt, then please message me on the chat box. So these are the 1 mark question. Okay, and you need to solve it like this. Now the second part is, second type of questions are like this. In these questions, they will ask you to solve the system of equations. In the previous question, they will just ask you to check the consistency, that the solution, that the system of equation is consistent or inconsistent. Okay, so that will be 1 mark question. Now in these types of questions, they will ask you to solve the system of equation. Okay, so we will check how can we solve this. So in these type of cases, how, first of all, we need to write A. Who can tell me? Josefa, can you tell me what is A? What is matrix A? Very good, Josefa. 2, 5, 3, 2. Very good. Okay, then X you already know. X is what? Variable X and Y. Okay, then B is what? B is 1, 7. 1 and 7. Very good, Josefa. So we know the formula that X is equal to A inverse B. There is no need to do the derivation. Okay, we will always use this formula. X is equal to A inverse B. So in this question, what we need to do, first we will find the A inverse and we will multiply that with B. Okay, let me check. We have one more question of this type of or not. Okay, no. Okay, then you will solve it. X is equal to A inverse B. Now A inverse, you already know how you need to find A inverse. So please find A inverse, multiply that with B, and that will be your answer. Okay, so Uni, please complete this question and then you can drop off. Okay, so this was the last topic of today's class. If anyone have a doubt that how we need to find the inverse, then let me know. I will help you in this. So all of you, please find the inverse and put in this equation. X is equal to A inverse B. Hey Noma, let me check. Noma, y is correct. Y is minus no. Atif, your answer is correct. Y is minus 1. X is equal to 3. Noma, please check the calculation. Answer is X is equal to 3 and Y is minus 1. Okay. And if anyone have a doubt, then please let me know. I will solve this. Noma, very good. This is correct. Okay, Sav. So you find out the answer like this. X is equal to 3 and minus 1. Okay, then Sav, please write like this, that what is X? X is X and Y. And this is equal to what? 3 and minus 1. So X you will get 3 and Y you will get minus 1. Okay, so this will be the final answer. Very good, Sav. Your answer is correct. Please write your answer in this way. Okay. And all the other students, please share your answer. Okay, so that we can start the next one. And only if this is done, then you can drop off. Therefore, this is done. Yashika, this is done. Shall we start next?
Yes, sir.
Okay. Yashika, you're getting the same answer?
Yes, sir.
Very good. Josefa, this is done. Or you have a doubt in this? Okay. Getting the same answer, Josefa? Okay, great. Now, the next type of question is this one. In this equation, we have a 3 variable. Okay. So most of the time, they will ask you to find the value of 3 variables. Okay. Normally, they do not give the questions of 2 mark. Sorry, of 2 variable. So same method, please try to solve it and share your answer. And let me know if anyone have a doubt in this one. Okay.
So what do you mean by matrix method?
Okay. Matrix method is the same one which we have discussed just now. Okay. The same, the determinant and matrix method. Okay, sir. The method which we have just used, that is a matrix method.
Okay, sir.
If anyone have a doubt, okay, please let me know. Noma, very good. X is not -1. Okay, this is the correct answer, Noma. X is 1, Y is 2, and Z is 3. Will you please again check your answer? Noma, this is the correct answer. Okay, please check this.
सर डिटर्मिनेंट ए की क्या वैल्यू है?
Determinant of A, I will find this. Determinant of A, this is equal to, no, I guess everything is fine. You might have done a mistake in finding the cofactor. I will solve it. 3 minus 2, 3. 2, 1 minus 1. And 4 minus 3 and 2. Okay, so this is equal to 3. So this is 2 minus 3 plus 2. 4 plus 4 minus 3. So minus 6 minus 4. So this is equal to 3 into minus 1 plus 16 minus 10 minus 3, okay, plus 16 and plus 30. So this is equal to 13. So this is 43. Okay, Noma?
सर मेरा तो -17 आ रहा है.
Minus 17. Let me check this again. So 2 minus 3 is okay. Plus 2. 4 plus
सर आपने किसके अलोंग एक्सपेंड किया है?
along the first row.
फर्स्ट रो. तो फिर सर यहाँ पे -2 नहीं आएगा?
Just give me a minute. Just give me a minute. Everything's fine. यहाँ mistake हो गया. Plus 3 है. और ये है -6 and -4. So there's plus. This is minus. Okay. Okay. So this is 13, 23 and minus 17. Noma, ये negative हो जाएगा Noma पे.
यस सर.
Okay, and this one is positive. So minus 17. Atif, Josefa, Seth, this is done.
1 minute, sir.
Okay, okay. Yashika, please share your answer once it is done. Okay, and let me know if you have any doubt in this. Sorry, we have only 3 minutes. Okay, so please note down this answer. X is 1, Y is 2, Z is 3, and give me a minute. I will give you the homework for today's class. Okay. Okay, so time is up. Okay, please note down the homework. Homework is assignment 5th. Okay, just give me a minute. Okay. Assignment from 1 to. So I hope most of you have completed assignment 1 to 4. So assignment 5th is based on the inverse. Okay, or we can say application, which the topic which we have completed today. Application. Okay, so please complete this assignment 5th till tomorrow, and tomorrow hopefully we will complete this chapter. Okay, so thank you all of you. We will continue this topic tomorrow.
Thank you, sir.
Okay, you're welcome. Okay, Yashika, you're welcome.
Thank you.
You're welcome. Maziha, Josefa, you're welcome. Maziha, you have just joined. My voice is audible, Maziha? Okay.
Sir, for why I'm getting 1.8.
1.8. No, sir, that's not correct. Sir, what's the value of determinant you are getting?
Minus 17.
Minus 17, that's correct. Okay. So, Maziha, what was the last topic which you have done? Maziha, what was the last topic? Sir, I will solve this question. Okay, we will check then. Maziha, what was the last topic? Maziha, please reply me, okay, so that I can tell you the topics which you have missed. So after that, we need to find the cofactor stuff. Okay, so cofactor will be find out like this. Remove this. So 1 minus 1 minus 3 and 2. So a11 will be equal to what? 2 minus 3, which is equal to minus 1. Next is a12. Mazia, please reply me. What was the last topic? You have done the formula exercise. The 3 cases you have completed. 2, 4 minus 1, 2. Okay. So this
Sir,
is,
I got the answer. It's correct.
you got the answer. Very good, sir. Please note down this. Okay, sir, then complete the homework and we will continue this tomorrow. Okay.
Okay, sir.
Okay, good. Okay, so Mazia, I guess you have missed the complete today's class. Okay, Mazia, then please do it and let me know in the next class if you have any doubt. Okay. Okay, thank you.
Thank you, sir.
Okay, sir, you're welcome.